Hello, welcome to Unit 7, Rational Functions. So this is going to be day 1. We're going to learn simplifying rational expressions, so this is video 1. Just so you guys can see differently than what we did from the last time we did notes, on the left side here, you have Cornell notes, so you could take all of your notes on the left side, any key concepts, any questions that you have, you'll put it on the left side over here. So I'm going to go ahead and get started. So we're going to talk about rational expressions. So a rational expression is simplified when the numerator and denominator have no common factor other than 1. Okay? And I'm going to show you exactly what this means through the problems. So just remember this main thing, that you can only divide out common factors, not terms. And as we go through it, I'm going to show you in the problems what I mean by that. So right here, I wrote out all the steps for you. So steps to simplifying a rational equation. We're going to completely factor the numerator and denominator if necessary. We're going to cancel out any factors that are common to both the numerator and denominator. And then we're going to rewrite our simplified answer. So let's go ahead and start with the first one. And this first one says x times x plus 5 over x squared. The numerator is already factored for us, okay? But the denominator is an x squared. And we can also look at this x squared as x times x. And I'm going to pull it apart for a reason, and then we'll talk about it. We'll make it x times x because x times x is x squared. The whole point of this is simplifying this expression. So to simplify it, we want something that's the same on the top and on the bottom. And in this case, when we pull apart that x squared, these two x's cancel out. So you guessed it, our final answer for this would be x plus 5 over x. Now here's that part where I said to you guys, remember that you can only divide out common factors, not terms. Right here we have x plus 5 over x. This would be your final answer. I know some of you are saying, well, why can't we take out those x's? Why can't those simplify? When you have a factor, let me do this for you, and that might look more like a factor to you. All right, this is one term, okay? X plus 5 is a number. It's one term. So we can't just divide the top x that's in the numerator by the x in the denominator. So our answer would be x plus 5 over x, okay? Let's go ahead and look to the one to the right. X squared plus 3 over x. Can you factor out x squared plus 3? If you answered no, that's right. You cannot do x squared plus 3. We have an x, we have an x squared. There's nothing you can do with this problem. So our answer would be x squared plus 3 over x. Okay, sometimes we just try to trick you guys. All right, so let's move down to something like these two over here. Now, I hope you brushed up on your factoring, because if you didn't, this might be a little difficult. So my suggestion to you is make sure that you know how to factor. Come see your teachers if you need extra help for that. So let's look at this one. Remember the steps. The first step was to completely factor the numerator and denominator if necessary. So let's go ahead and factor this. So this is a trinomial. What I do is I look at this sign right here, and that's a minus sign. That tells me my signs are going to be different. Because I know this is a trinomial, I know it's going to factor into two binomials. First term is x squared, so I do x and x. Again, like I said, this minus sign tells me my signs are different. And this minus sign right here tells me that my larger sign is going to be minus. So we have a minus and a plus. I just do that to keep myself organized. And then I think to myself, I have to find the factors of 12. So I just go on the side and I say 1 times 12, 2 times 6, 3 times 4. I realize that my larger number has to be negative. And when I mean larger, I mean all of these numbers out of these two factors that you have. So which ones over here, when added together, are going to give me minus 4? So I look at 1 plus negative 12, that's negative 11. 2 plus negative 6, that's negative 4, that works. But just check this to be sure. 3 plus negative 4 is negative 1. So our numbers that go in these factors should be 6 and 2. Okay, so we just factored the numerator. The denominator, we have x squared minus 4. You should all say, oh, this is the difference of squares. So of course we know difference of squares is x minus 2 and x plus 2. Again, if you're having trouble factoring, please see your teachers. All right, so let's go up here and let's look at what the second steps are. Cancel out any factors that are common to both the numerator and the denominator. So do you see any common factors? I see x plus 2 on the top and bottom. I'm left with x minus 6 over x minus 2. Those are factors, okay? So our final answer would be x minus 6 over x minus 2. And remember, we cannot simplify this at all because these are factors. So I can't cross out those x's and I cannot simplify the negative 6 and the negative 2 to 3. It has to stay as x minus 6 over x minus 2. Let's look at the next one. This one is one of your favorites, I know for sure, because we're looking for a GCF. Don't forget about that. So we need the GCF. In the numerator, we just have 3 times x squared. There's nothing you could do with that. You can't factor that. You can't really do much. But in the denominator, we do have a GCF. So let me give you a second to think about that. And we see that we could take out 3x, and then what's left? So remember, when you're taking out a GCF, what you're doing is you're pretty much just dividing these terms by 3x. All right? So if I divided the first term by 3x, I'd have x squared. And if I divided the second one, I'd have plus 7. And of course, you could check your work by distributing that 3x to make sure that you'll get 3x to the third plus 21x. Can I continue to factor that x squared plus 7? The answer would be no. There's no such thing as the difference, or I'm sorry, the sum of squares. Obviously, 7 isn't a perfect square either. So now we look at this and we say, okay, step number 3 says to cancel out any factors that are common to both the numerator and denominator. Well, in the top, I see a 3 times x squared, and I see a 3 times x times this factor, x squared plus 7. So I could cancel out my 3's. Those cancel each other out. What about the x squared and x? If you could think back to Algebra 1, you could think of this x as having a 1 there for the exponent. So when you have x, and I'm just going to do it all over here for a second. If you have x times x, which is x squared, over x, you can cancel out these x's, and you're left with just an x in the numerator. So that's what we're going to go ahead and do. We're going to cancel out each of those x's, and I'm going to rewrite my answer. All right, you got to try to be a little neat about this so that you don't lose any of your terms. So your final answer here should be x over x squared plus 7. And I usually put it with the parentheses so it reminds me that it's a factor and that I cannot simplify it. So if you get in the habit of doing that, you should be good. All right, let's go ahead and flip to the next page. Again, you still have your Cornell notes over here. Take notes on this page, any key concepts, any questions for class tomorrow. All right, so now as we look through here, you're going to see steps to multiply a rational equation. So we're multiplying here, okay? You see the steps. One of the key things that I want you to remember is to not multiply your expressions back together after you have factored, okay? So I'm going to go through, and the first one that I did here, I kind of did a little easier one, per se, so that you can see what I mean, and then we're going to go into something a little more difficult below it. But again, something that you know how to do, as long as you know how to factor and simplify, you'll be fine. So we look at the top and we have to see, can I factor anything in the numerator and denominator here? Well, you can factor the numerator. So again, I'll just say it the way I do it. It's a trinomial x squared, so I know that the first two terms are going to be x and x, and then I look at the signs. This sign tells me that the signs are different, and this tells me my larger is negative. So when I mean different, I mean one is positive and one is negative. Doesn't matter which one you put where, but for me, because I know the larger number is negative, I put it first. Then I put the factors of 6. 1 and 6, 2 and 3. And remember when I said that the larger one has to be negative, so that means 6 is the larger one out of 1 and 6, 3 is the larger one out of 1 and 2. So I put my negative signs there. Now, when these two terms are added together, which one's going to give me negative 5? And this one's always tricky, but it's going to be 6 and 1. All right? And the denominator you're welcome, is already factored out for us. So I'm just going to rewrite it. You're going to be doing a lot of rewriting in these types of problems. And now that next step is simplify where necessary by canceling any common factors. So where are the common factors that you see here? I see x minus 6 and x minus 6. So those go away. Is there any other factors that's the same on the top and bottom? No. So we're just going to rewrite our answer as x plus 1 over x plus 8 times x minus 2. And that's how we leave our answer. Now remember when I put these green stars over here and I said do not multiply your expressions back together after you have factored. This example is a clear problem that shows you do not take this x plus 8 and x minus 2 and then FOIL them out to get a trinomial. We don't want you to do that. You can leave it as this and that would be perfect. So let's go down to this next problem. Okay? We have 4x squared minus 4x over x squared plus 2x minus 3 times another fraction, which is x squared plus x minus 6 over 4x. So what we need to do is it's the same thing we just did up here, all right? Same thing we just did, except it's two different fractions. So first step was to factor it. So let's factor the numerator for this first one. So when we factor it, again, this is GCF. You should be able to see that. So we're going to pull out 4x, and we're left with x minus 1. Do not forget that minus 1, you need a placeholder. So now if I was to redistribute the 4x, I'd get 4x squared minus 4x. So that works perfectly. And this is over. And we're going to go ahead and factor. I see that the signs are different. The larger one's positive. So x plus and x minus. And the only factors of 3 are 3 and 1. So I know that it has to go like this. Now I'm multiplying to the other fraction, okay? The numerator I can factor. So I know that I have a trinomial, so it's going to break into two binomials. First term is x. Signs, again, are going to be different. Larger one is positive. And then I need the factors of 6, which are 1 and 6, 2 and 3. And the larger one is positive, which to me means the smaller one is negative. So when added together, which one's going to give me positive 1? It would be 3 and negative 2. So 3 goes with the plus sign, 2 goes with the minus. And then in the denominator here, we have 4x. Now immediately, you should see that there are things that you can cancel out that are the same on the top and bottom. So you have this multiplication sign here. How do we multiply fractions? Think about this for a second. Now, if you told me to cross multiply, I am going to come into your classroom and yell at you because you should know better than wanting to say to cross multiply, okay? Remember that when you multiply fractions, you're multiplying straight across. So what I do when I show how to do this is I just do one line like this. So what that means is 4x times x minus 1 is now multiplied to x plus 3 times x minus 2, and then the denominator is multiplied to itself. So anything that's in the numerator or on the top, you can simplify with anything that's in the denominator or the bottom. So I like to look at the factors first, so I see x minus 1 and x minus 1 here. I see x plus 3 and x plus 3. Those both cancel. And then I see 4x and 4x. It's 4 times x. Because it's being multiplied, we can cancel them out. So what are we left with? Yep, this nightmare just left you with the answer, x minus 2. Okay? So you can see why we stressed how factoring is very, very important for you guys to understand, because if you can factor these problems, we'll go fast, because obviously the simplifying part should be kind of easy. All right, now this last one. This last one looks a little different. Usually what we did in this second one was we factored here, and we factored, and then we multiplied them together and simplified. Well, in this one, you can multiply straight across. So remember what I said. You just make that multiplication sign one whole thing, and we can multiply straight across. So this is going to be multiply. So I get, remember you have to multiply like terms. So you want to multiply the numbers with the numbers and the variables that are the same with the variables that are the same. So for example, here we would do 5 times 6, which is 30. We would do x squared times x to the negative 3. So I want you to remember, and I'm just going to write it on the side over here. I like the space for the notes. You're going to multiply these together. So when we multiply exponents, what we're doing is, think back to algebra 2, is we add these numbers together. Okay? So 2 plus negative 3 would be x to the negative 1. All right? And we'll get to that when we simplify. We have y to the first times y to the second. So think about it. Y to the first times y to the second. We just add the exponent. So it would be y to the third. And then in the denominator, remember, numbers with numbers, variables with variables. So 2 times 10 is 20. X has nothing to be multiplied to, so we do x. And then y to the third times y to the first. I like to look at it as I have y to the fourth. Now, once I'm at this part, I don't say, hooray, I'm done. I'm going to leave it because I know how to multiply fractions. We need to multiply, and then we simplify. Okay? We're going to multiply, then simplify. So remember, numbers with numbers, variables with variables. So here I want to simplify 30 and 20. So I remember that you can divide each of these by 10, so those zeros go out. And I'm going to start writing my final answer here. So I have a 3 in the numerator and a 2 in the denominator. All right, now I have x to the negative 1 over x. Remember, if you're multiplying, we're going to add my exponents. So what do I do if I'm now dividing? You're going to subtract, okay? So what's going to happen is I have negative 1 here, and I have 1 in the bottom. And what happens is if I do x to the negative 1 minus 1, I get x to the negative 2. Now notice this x to the negative 2, that's in the numerator right now because this is like over 1. When you have a negative, all it means is that it flips to the denominator. So if it's in the numerator like it is here, it's just going to go into the denominator to make it positive. If you have a negative in the denominator, it would flip to the numerator to make it positive, and the number would stay the same. So in this case, you could think of it as flipping down here, so you're just adding 1 to there, so you'd have x squared in the denominator. And again, that's the same thing as x to the negative 2 power. And then this last one, we have y to the third over y to the fourth. And here's another way to look at it. I sometimes say, well, if there's 3 y's at the top, 1, 2, 3, and 4 y's in the denominator, okay, you can cancel them out. 1, 2, 3, and where's that last y? It's in the denominator. Okay, so there's a bunch of ways that you can figure out these exponents. So your final answer here should be 3 over 2x squared y.
Mr. Mackey, please call extension 2614. Mr. Mackey, please call 2614.
That's right, Mr. Mackey. Make sure you call 2614 because you are in trouble. All right, so let's move on to dividing rational equations, okay? So 2 steps. Multiply the first expression by the reciprocal of the second, and then follow the multiplying steps. And I think I missed a y in there, so sorry, which is on the previous page. So remember these 3 words. I've been teaching this for 6 years. These 3 words are going to help you learn how to divide a rational equation, because I have to be honest with you, there is no such thing as dividing a rational equation. All you're doing is stay, change, flip, and you're multiplying. So you can look at dividing rational equations as multiplying rational equations, which is what we just did. So remember, stay, change, flip. And I wrote exactly what it means up here. The first fraction stays the same. The sign changes from division to multiplication, and you flip the second expression. And we're going to see it in this example right here. But I made it a little more complicated because I feel like you can handle it. Okay? Normally we would see something like this. If we did x squared over x divided by x to the third over x to the fourth. What stay, change, flip is this. We would keep the first fraction as the same, the sign would change from division to multiplication, and we'd flip the second expression. And that's the reciprocal. And then, of course, we would simplify this. So you can write this one out. I just made this one up. But x to the 6th over x to the 4th, and that would just equal x squared. Okay, so that's just like a little example for you guys, so you could kind of see it in an easier way. So what I'm going to do to help you out right here is we're going to do the state change flip before we do anything. So I see in this problem right here, I have this fraction and this trinomial, and I'm multiplying them together. So this is really x squared minus 5x minus 14 all over x to the 3rd minus 6x squared minus 7x times, now how would I put this trinomial as a fraction? You just put it over 1. So x squared minus 4x minus 5 all over 1. Now here's where the state change flip comes into, because I have that division sign there. So here's that first fraction that's staying the same. Now I'm going to change the division to multiplication. And we go ahead and we flip the second expression. So we flip it, and it should be 2x over x squared plus x minus 30. Okay, so here is where factoring comes into play. This looks like a nightmare, I know. But if you know how to factor, you're just going to cancel, 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 and you're going to have a nice looking answer. So let's go ahead and factor this one together. X squared minus 5x minus 14. So we need to factor this. So I know it's going to be two binomials, x in the beginning. I see that the signs are different. The larger one's negative. Factors of 14 is 7 and 2. And that's going to work for there. Denominator. Is there a GCF? Yes, there is. It's x. So you got to pull out x. And you pull out x, and you're left with x squared minus 6x minus 7. Can you continue to factor this trinomial? The answer is yes. So you need to factor this, and I'm just going to do it below. X times, and I'm writing over this problem, sorry, x minus 7 and x plus 1. All right, make sure that works. Now that you see what the answer is, I'm just going to rewrite it over here so that it's not on top of that other problem. So we said times x minus 7 and x plus 1. All right. Now we have this next one. We've got to factor this. I'm just going to leave it over 1. That's okay. So I have x and x. Factors of 5. There's only 2, and it's 5 and 1. Make sure that works. Perfect. And then the last one, which 2x, we cannot simplify. And then we need to factor the denominator, which should be x and x. Signs are different. Larger one's positive. And I think of factors of 30 are 1 and 30, 2 and 15, 3 and 10, and 5 and 6. And that's going to be what it is. 6 and 5 is going to give me this plus 1 right here. Okay? This is completely factored. Okay? So see how I went from the first part to rewriting it so that it's all multiplication, then factoring it, and now what do? We cancel. We want to get rid of anything that's the same. Now remember about what it means to multiply fractions. We just go straight across, okay? So anything that's in the numerator can be canceled with anything that's in the denominator. So I have, let's see, I have an x minus 7 and an x minus 7. I have an x minus 5 and an x minus 5. I have an x plus 1 and an x plus 1. So what I still have here is x plus 2 and 2x. And notice that I have an x down here. So I could cancel this x with this x. And I also still have this. So my final answer with this nightmare of a problem would be 2 times x plus 2 all over x plus 6. And that would be my final answer. Okay, so look at that for a second. Remember that we cannot simplify the 2 with the 6. That wouldn't work. We can't cancel out the x's. That's our final answer. All right, so what I'm going to do is I'm going to go down to this next problem. And I hope you can write as fast as I can, because I am going to erase all this. So make sure that you have it all written down. And we're going to go ahead into this next problem. Now you're going to say, oh my gosh, what is this? This is crazy. You have a fraction, you have two fractions within a fraction. And you're going to shake your head and you're going to say, I don't know how to do this, I can't do this. That's not true, okay? What does this fraction bar mean? This fraction bar means to divide, okay? So let me show you what this really should look like. X stop.